Imagine looking up at the night sky and realizing something impossible is happening right above our heads. It's March 26, 2026, and just 6 hours ago, the 18th Space Defense Squadron at Vandenberg Space Force Base recorded an event so improbable it defies everything we know about physics. I'm not talking about a collision. I'm talking about the exact opposite. At 9:14 UTC, an object called S3I Atlas passed within 40,000 kilometers of the geostationary belt, and something extraordinary occurred. Every single piece of space debris, old satellites, spent rocket stages, even paint flecks smaller than a centimeter, suddenly changed trajectory. They didn't hit the object, they were pushed away. Picture it, a sphere of influence, exactly 400 kilometers in radius, expanding around S3I Atlas like an invisible force field. Inside this zone, there was nothing, a total vacuum, like the Red Sea parting, but on a cosmic scale. For decades, we've tracked over 27,000 pieces of orbital debris, warning about the Kessler syndrome, a chain reaction of collisions that could trap Earth in its own orbit. We've spent billions designing lasers, nets, and robotic collectors to catch even one piece of junk. And yet, in just 14 minutes, S3I Atlas cleared a path through the densest part of our orbit without a single collision. NASA's Goldstone radar confirms it. The tracking station in Malargüe confirms it. And here's the kicker. The debris wasn't just nudged, it accelerated away at 3.4 kilometers per second, perpendicular to the object's path. The only way to do this with conventional physics would be with a repulsive force of unimaginable magnitude. Gravity only attracts. Electromagnetism can repel, but space debris is made of aluminum, titanium, composites, materials that respond differently to magnetic fields. And yet, every piece of debris moved with the same force. The precision of this phenomenon is terrifying. If this were a natural magnetic anomaly, every active satellite in that sector would have fried instantly. The Starlink constellation? Unaffected. Ghost weather satellites? Perfectly functional. Only the dead junk moved. This is not random, it's selective. To grasp the full scale of this event, we need to understand the path S3I Atlas has taken. It entered our system on March 23, 2026, crossing the lunar orbit, behaving like a massive interstellar object. But as it approached geostationary orbit, 35,786 kilometers above the equator, its behavior shifted from passive to active. At 12:05 UTC, the U.S. Space Surveillance Network noticed a massive fluctuation in Sector 4, a graveyard orbit cluttered with satellite husks from the 1970s and 80s. Normally, objects here drift for centuries, but suddenly, thousands of debris fragments began moving outward at once. ESA's optical ground station in Tenerife verified the phenomenon independently. Japan's JAXA cross-referenced the orbital mechanics. 3 independent agencies, 3 different methods, one conclusion. The debris wasn't drifting, it was being shoved. Now pause and consider the implications. Normally, when 2 objects interact, force is transferred via collision or a field. If S3I Atlas had simply plowed through, it would look like chaos, a spray of fragments like billiard balls scattering. But the data shows order. Every single piece of debris within a 200-kilometer radius experienced identical acceleration, a snowplow clearing a road without ever touching the snow. And here's where it gets even stranger. The debris isn't uniform. You have 2-ton rocket bodies, old steel stages, glass solar panels, insulation, plastic, copper. Normally, a magnetic field or an electromagnetic push would affect each differently. A magnet picks up a paperclip, not a rubber band. But S3I Atlas pushed them all equally, mass independent. Every object, no matter its composition, moved the same distance at the same speed. At 1430 UTC, it passed within 15 kilometers of a functioning telecommunications satellite, Intelsat 40E. If this were a natural phenomenon, the satellite would have been shoved, its orbit disrupted. Instead, the repulsive field switched off for just 3 seconds, the satellite stayed stable, and then the field resumed. Nature doesn't make choices like this. Gravity doesn't spare one object and push another. A magnetic anomaly doesn't toggle on and off. This was deliberate. The pattern is clear. S3I Atlas isn't a rock. It's curating its path, clearing debris like a gardener pruning a hedge. And the data from the energy readings is even more astonishing. To move 30,000 kilograms of debris across 400 kilometers without generating heat, that violates every law of thermodynamics. In fact, the ambient temperature actually dropped by 4 Kelvin. Energy was extracted from the vacuum itself, not from combustion, not from solar panels extracted from the space around it. Then, on March 24th, the repulsion field began pulsing. The Parkes Observatory in Australia detected a low-frequency hum at exactly 1,420 MHz, the hydrogen line. The universal frequency SETI scientists have predicted intelligent civilizations would use. And here's the twist. S3I Atlas wasn't broadcasting to us. It was synchronizing its repulsion effect with the hydrogen line. When the signal pulsed on, the debris moved. When it pulsed off, it drifted. A binary rhythm, on-off, coordinating every move. The odds of a natural comet doing this? Statistically 0. Winning the lottery every second for a week would be more likely. Even the skeptics at Harvard are silent. This is where the story stops being about physics and starts being about something else entirely. Technology or intelligence, manipulating the very fabric of space itself. Imagine a bowling ball on a trampoline, curving the surface down gravity. Now imagine something doing the opposite, creating a hill and sliding objects away from itself, cold, silent, precise. That's what S3I Atlas is doing right now, above our planet, and we've only just begun to understand it. As S3I Atlas cleared a path through our orbit, what we initially thought was just a defensive shield revealed a far more unsettling truth. The object isn't merely repelling debris, it's harvesting it. On March 24th, at 23:45 UTC, the KEK Observatory in Hawaii trained its massive mirrors on the trail left behind the object. What they expected to be empty space or a simple scatter of particles turned into something extraordinary. Spectrometer readings revealed a chemical signature impossible to ignore: vaporized aluminum oxide and titanium dioxide, the exact materials that compose the hulls, shielding, and paint of old satellites. Here's the chilling part. The larger debris was expelled outward, but the tiniest fragments, micrometeoroids and paint flecks under 2 millimeters, didn't get pushed away. They vanished. And within 40 seconds, a plume of ionized gas shot out from the back of S3I Atlas, containing the precise atomic ratios of the vanished material. Simply put, the object is eating space junk. It's not random. It's a functioning system, a ramjet of interstellar proportions, converting orbital debris into energy or propulsion. If this were a natural phenomenon, a rock spontaneously developing a digestive system capable of distinguishing valuable metal from useless plastic, the odds are effectively 0. The alternative? A self-sustaining, intelligently engineered probe refueling itself using materials from our own orbit. By 2 UTC on March 25th, the consequences became even more alarming. After harvesting roughly 400 kilograms of debris, S3I Atlas executed a powered maneuver. Using the energy it generated from consuming orbiting material, it fired a precise 1/4-second burn, not a gravitational slingshot, not a chaotic spin slowing its orbital velocity relative to Earth and initiating a controlled descent. It was no longer a passive object. It was now moving intentionally, heading closer to our planet. The trajectory is undeniable. At its current rate, within 48 hours, it will intersect the orbit of the International Space Station. NASA has already triggered emergency protocols. The astronauts aboard the ISS are preparing for potential evacuation, sealing themselves inside Crew Dragon and Soyuz capsules, ready for the worst-case scenario. This is no longer about monitoring an interstellar visitor. It's a matter of immediate planetary defense. When the head of NASA's Planetary Defense Office first saw the updated trajectory, her words were stark. This is not a comet. This is a salvage operation, and we are the scrapyard. Every fact we have now supports that statement. A repulsion field cleared a 400-kilometer cylinder of debris, confirmed by the U.S. Space Force. Spectroscopic analysis confirmed vaporization of aluminum and titanium, materials alien to natural cometary processes. And the maneuver itself? Powered propulsion that defies Kepler's laws. But perhaps the most troubling question remains unanswered. Why is it targeting the ISS? Is S3I Atlas harvesting only because it needs fuel, or is it acting strategically? One possibility is benign, a cosmic janitor, removing orbital debris to prevent Kessler syndrome and protect us from our own negligence. But the alternative is far more unsettling. Consider, the first thing a strategist does when planning an incursion is clear the minefield. Remove obstacles, neutralize observation posts, open a path. By clearing our debris field and aiming at the ISS, S3I Atlas may be doing exactly that. It's demonstrating choice, precision, and intent. This is not random physics, this is tactical behavior. The object identifies which material to consume, which to repel, and when to toggle its repulsive field to avoid active satellites. It has discriminative intelligence, or at least the functional equivalent of it. The ISS, the most significant observation outpost in low Earth orbit, is now directly in its path. It's not merely passing through anymore, it's hunting. As we speak, the ISS is in free drift, cameras locked on the incoming vector, astronauts bracing for the unknown. Every telescope trained on S3I Atlas is transmitting live data. Every passing minute is critical. Within the next 14 hours, it will reach its closest approach. We will finally see whether this object is here to communicate, to consume, or to exert control over our orbital assets. And the deeper question lingers. If S3I Atlas is intelligently harvesting, where will it go next? Could it continue consuming orbital debris across low Earth orbit, building fuel reserves for further maneuvers? Could it extend its reach into the lunar orbit, or even beyond, using materials from satellites to sustain itself as it navigates the solar system? Every decision it has made so far suggests foresight, strategic planning, and an awareness of our technological infrastructure. In short, we are witnessing a phenomenon that challenges every assumption about interstellar objects, celestial mechanics, and energy management in space. This is not just a comet, nor a rogue asteroid. This is something engineered, directed, and purposeful, capable of manipulating matter, energy, and trajectory with unprecedented precision. And right now, the clock is ticking as it approaches the ISS, the ultimate test of its capabilities. As S3I Atlas closes the distance, the situation in orbit has escalated from curiosity to urgent crisis. Every passing second brings it closer to the International Space Station, and every instrument pointed at it is picking up anomalies that defy conventional physics. Observatories around the world are working in unison, feeding real-time telemetry into supercomputers at NASA, ESA, and the Space Force. But even with all this technology, the readings continue to challenge every known model. The most immediate concern is trajectory. S3I Atlas is no longer in a simple orbital path. Its powered maneuver has created a decaying spiral that will intersect with the ISS's orbit within the next 14 hours. The space station, typically a stable platform in low Earth orbit, is now in a dynamic situation where the difference between survival and catastrophe depends entirely on anticipating the object's next move. Emergency thrusters are primed, crew evacuation protocols are active, and all systems are being monitored in real time. But no conventional calculation can fully account for the behavior of an object that actively repels and consumes debris, converts it to thrust, and manipulates its trajectory with apparent intent. Meanwhile, the energy signature of S3I Atlas has left scientists baffled. During its clearing event, the object expelled debris at velocities exceeding 3.4 kilometers per second, yet thermographic readings indicate no corresponding heat generation. In classical physics, any kinetic energy transfer this massive would produce a significant infrared bloom. Instead, telescopes detected a localized cooling of the surrounding debris field by 4 Kelvin. That's not just improbable, it violates the second law of thermodynamics as we understand it. The object appears to draw energy from the vacuum itself, converting potential energy in ways our current physics cannot explain. Adding another layer to the mystery is the pulsed radio signal detected at the hydrogen line frequency, 1420 MHz. This frequency, long considered a universal beacon for intelligent life, isn't being used to communicate in any human sense. Analysis shows the pulses are synchronized perfectly with the repulsion field. When the signal is active, debris is accelerated outward. When inactive, objects remain stationary. The probability that a natural body could generate a coherent, perfectly timed signal that manipulates its environment in this way is astronomically small. The conclusion is unavoidable. The object is behaving like technology, and a technology that manipulates the fundamental forces of space-time itself. As the hours tick down, attention has shifted from observation to potential intervention. International space agencies are coordinating contingency plans, though the scope of control is limited. S3I Atlas is not just moving, it is actively interacting with its environment in ways that suggest intentionality. It differentiates between active and inactive objects, avoiding satellites with functioning electronics while consuming defunct material. This is a level of precision that implies either a highly advanced autonomous system or an intelligence we cannot yet comprehend. The ISS itself has become a focal point. It contains vast amounts of easily harvestable material, aluminum, titanium, rare earth metals, and complex electronics. For S3I Atlas, the station is not just an obstacle, it is a resource. As it approaches, engineers and astronauts must consider multiple scenarios. The object could harvest non-essential components and move on, or it could disrupt critical systems, potentially forcing a full evacuation. The crew has been briefed extensively, with life support backups and emergency egress fully activated. Simultaneously, the tracking data is producing patterns that seem deliberate. The object's acceleration and pulsing sequence correspond to a rhythm that is almost binary in nature, a repeating on-off pattern that perfectly aligns with the positions of active versus inactive orbital objects. This implies not only selective interaction but also a form of environmental mapping, as if S3I Atlas is analyzing and reacting to its surroundings in real time. What's particularly alarming is that all observations point toward a single, undeniable fact. This is not natural. The statistical odds that a comet or asteroid could spontaneously evolve these capabilities, force manipulation, energy absorption from the vacuum, selective debris interaction, are effectively zero. We are observing the manifestation of something designed, something capable of intelligence, or at least programmed logic that surpasses anything humanity has created. At this moment, as S3I Atlas continues its controlled descent, The world's eyes are fixed on its approach. Every telescope, radar, and spectrometer is live, recording the most unprecedented orbital event in human history. In just a few hours, we will see whether the object's trajectory aligns with our predictions, or whether it will take an action that could redefine our understanding of extraterrestrial technology and our place in the solar system. The stage is set, and the countdown is real. The next hours will reveal whether S3I Atlas is a collector, a cleaner, or something far more deliberate, an autonomous entity capable of strategy and choice, converging directly on the ISS, the most critical orbital outpost humanity has ever built. As S3I Atlas closes in on the ISS, the situation has escalated into a full-blown orbital emergency. Every orbital monitoring system is live, from NASA's Johnson Space Center to ESA's ground-based telescopes, and the data streaming in is unlike anything ever recorded. The object's descent is not passive, it is controlled, deliberate, and frighteningly precise. Engineers aboard the ISS are running simulations in real time, but even the most advanced predictive models struggle to keep up. This is no longer about avoiding a collision, it's about anticipating an intelligence operating at a level far beyond our technology. The energy signature of S3I Atlas continues to confound scientists. During its approach, its repulsive field has expanded and contracted in ways that defy classical mechanics. Objects within a 400-kilometer radius continue to be pushed outward, but the force is finely tuned. Functional satellites remain untouched, while defunct debris is accelerated outward or pulled inward. Spectroscopic analysis confirms that the materials being consumed, aluminum oxide, titanium dioxide, and other metallic remnants, are directly sourced from older, derelict satellites. S3I Atlas is feeding on orbital junk with astonishing efficiency, converting mass directly into propulsion. It's a self-sustaining system, using what humans have left in orbit as fuel for its maneuvering. The repulsion mechanism itself is extraordinary. Observatories have confirmed that the force is mass-independent. A 2-ton rocket stage is pushed with the exact same acceleration as a tiny paint fleck. It's as if the object is bending the rules of physics, manipulating gravity or inertia to achieve uniform motion across materials of wildly different densities and compositions. The possibility of this being a natural phenomenon is effectively zero. This is engineering on a cosmic scale precision that cannot occur without control, direction, and calculation. Meanwhile, the ISS crew is on high alert. Emergency procedures have been fully activated. Hatches are sealed, life support systems are redundantly powered, and Soyuz and Crew Dragon capsules are primed for immediate evacuation. Every maneuver is being coordinated with Mission Control in Houston, with ESA and JAXA providing parallel monitoring. The astronauts are calm, but the weight of the situation is clear. They are essentially the living observers in a real-time experiment with an object that operates according to principles unknown to humanity. Tracking data is producing patterns that suggest intentionality. The timing of repulsive pulses, energy emissions, and debris collection is not random. Every on-off pulse correlates to the location and activity of surrounding objects. It's as if S3I Atlas is mapping its environment, identifying which materials to avoid and which to harvest. Scientists have noted that the object's internal metallic core may be the control center for these operations, manipulating the surrounding ice and rock shell to generate the repulsive field while simultaneously extracting kinetic energy from absorbed materials. The precision is alarming. It is not only moving, it is selecting, analyzing, and executing actions with extreme efficiency. The global response has intensified. Space agencies worldwide have convened emergency briefings. The White House, the European Commission, and the heads of multiple defense organizations are receiving live telemetry. Classified communications confirm that all standard space defense protocols have been activated, yet there is little precedent for this type of object. Conventional planetary defense strategies assume threats will follow predictable Newtonian mechanics. S3I Atlas violates those assumptions at every turn. It is accelerating using harvested material, manipulating forces without detectable heat, and targeting objects selectively, all without relying on chemical propulsion. The trajectory analysis is now the primary concern. After its powered descent, the object has aligned itself to intersect the orbit of the ISS in just under 14 hours. Mission planners are running every conceivable evasion scenario. The station's current orbital altitude is 408 kilometers, with multiple modules and solar arrays extending outward. A direct impact would be catastrophic, but even near passage could disrupt power systems, communications, or environmental controls. Every adjustment the astronauts make is being calculated in real time. But S3I Atlas continues to demonstrate a level of predictive maneuvering that exceeds any known natural or artificial object. Beyond the immediate danger, there is the question of purpose. The object is clearly not acting randomly. It is clearing paths, harvesting material, and positioning itself in a trajectory that optimizes resource acquisition. But the selectivity-sparing active satellites, targeting debris, consuming specific metals, implies analysis, decision-making, and perhaps even a strategic objective. Is this a probe, a mining operation, or something far more deliberate? The answer will shape not only our response in the coming hours, but our understanding of interstellar technology. As the countdown continues, all eyes remain on the approaching object. Observatories, radar stations, and spectrometers are aligned, capturing every detail of the descent. Scientists are streaming live telemetry to predictive AI systems, but even the most advanced models are limited when the object is rewriting the rules as it moves. The next hours will reveal whether S3I Atlas acts purely as a collector, a threat, or something far beyond our comprehension. The clock is ticking, and humanity is watching a live demonstration of forces, energy manipulation, and intelligence that challenge every assumption we hold about objects in space. As the hours tick down, the situation around the ISS has become a high-stakes real-time experiment in orbital physics. S3E Atlas is no longer a distant curiosity. It is an active, intelligent actor in low Earth orbit. Tracking data shows that its powered descent has placed it on an exact intercept course with the station. But what is most extraordinary and terrifying is that it is not only moving with precision, it is interacting with its environment in ways that are clearly intentional. Every debris particle, every micrometeoroid is accounted for. Larger objects are pushed away, smaller ones are absorbed, and all of this happens without the slightest detectable heat or chaotic turbulence. The object is manipulating mass and energy in ways that defy our current understanding of physics. Spectroscopic readings from multiple observatories confirm that the material being absorbed by S3I Atlas matches the composition of the debris it is targeting. Aluminum, titanium, and rare metals from old satellites are pulled into the object's surface in synchronized bursts. Seconds later, ionized gas is expelled from the rear, generating propulsion. In essence, S3I Atlas is using the very remnants of human technology to power its own maneuvering. This is no random anomaly. This is an engineered, self-sustaining system that harvests fuel from its surroundings. Scientists now refer to it as a ramjet-like interstellar vacuum collector, and the energy efficiency is staggering. It is a machine of impossible precision, operating cold, silent, and with uncanny discretion. The ISS crew, fully aware of the object's capabilities, are executing emergency protocols at a moment's notice. All external robotic arms are stowed, solar panels are locked, and critical systems are redundantly powered. Soyuz and Crew Dragon capsules are on standby for immediate evacuation. Communication with mission control remains open, but the astronauts are essentially observers in a live demonstration of technology that exceeds anything humanity has ever produced. The reality is chilling. This object operates on principles we can only begin to theorize about, manipulating gravity, inertia, and kinetic energy in ways that suggest intelligence, control, and intentionality. The trajectory data is even more alarming. After harvesting approximately 400 kilograms of orbital debris, S3I Atlas has executed a controlled burn, reducing its orbital velocity relative to Earth. It is no longer a passive object in space. It is actively maneuvering, descending along a precise path. Its new course will bring it within immediate proximity of the ISS in less than 12 hours. NASA has issued a code red for orbital collision avoidance, and every international space agency is coordinating monitoring and predictive simulations. The critical question now is whether S3I Atlas intends to consume the ISS itself, to communicate, or to continue its passive collection. The behavior of S3I Atlas is unprecedented. Its selective repulsion field demonstrates discernment, distinguishing between active and inactive objects with absolute precision. Its harvesting system shows the capability to extract and utilize materials autonomously. Its trajectory adjustments indicate strategic planning. Taken together, these observations suggest that S3I Atlas is a probe or vessel designed for sustained interaction with its environment, capable of decision-making, energy management, and adaptive behavior. In short, it is not merely an object, it is an agent. Telemetry from the object shows that its energy systems operate in a way that is equally baffling. The kinetic energy required to accelerate debris outward while simultaneously pulling in smaller particles has to come from somewhere. Yet no heat signature or conventional energy emission has been detected. It appears to be drawing energy from the vacuum of space itself, or manipulating gravitational and inertial forces to achieve its effects. This is metric engineering in action, creating curvature in space-time to push and pull objects without conventional propulsion. A 2-kilometer-wide object performing such feats in Earth orbit is beyond theoretical physics. It is, in effect, a live demonstration of technology humanity has only speculated about. As the countdown to intersection with the ISS continues, the stakes have never been higher. Every agency, every observatory, every satellite tracking system is contributing to real-time models of S3I Atlas's trajectory, behavior, and energy output. The astronauts are prepared for immediate evacuation, yet the object has not yet shown hostility. Its actions so far have been calculated, efficient, and purposeful. But the combination of selective clearing, material harvesting, and precise maneuvering paints a picture of an object that could, if desired, dismantle the station for resources with surgical precision. The global scientific community is scrambling to interpret the data. The object's behavior is rewriting the rules of orbital mechanics, propulsion, and material science in real time. Every pulse of its repulsive field, every collected particle, every energy signature challenges decades of established physics. And yet, it continues along its path with perfect coordination, as if guided by a central intelligence, mapping, analyzing, and reacting to its environment with absolute precision. The next few hours will reveal not only whether S3I Atlas is capable of communication, but whether humanity's most advanced orbital installations are vulnerable to its actions.